Hello everyone, welcome to my YouTube channel. So, from today, I'm going to create a new playlist, and this playlist consists of all the cloud technologies, from like GitOps to MLOps. So we are going to discuss all the tools and technologies related to the cloud native, from Kubernetes to Docker to Captain to Knative, and all the technologies which come under the CN Cloud Native Cloud Foundation. So for today's video, I'm going to discuss about how you can monitor your own Kubernetes cluster using Elastic, Logstash, and Kibana. So this video is also an addition to the upcoming playlist. So you can subscribe to my channel so that you can get the notification about the upcoming videos which I'm going to add on to this playlist. So the next video will be how you can set up your own Kubernetes cluster into your local machine. So I will be giving you some shortcuts and how you can utilize like Civo Cloud to set up this all into your local system. So let's get started. Let me share my screen and then we will go ahead how you can monitor your own Kubernetes cluster. So wait a minute. Yeah. So for today's we are having like monitoring our own Kubernetes cluster. So we will use ELK Stack. ELK stand for Elastic, Logstash, and Kibana. So let's get started. Like first, I would like to introduce myself. Some of you know me, and some of you are new here. So let me introduce myself. So I'm Ritesh Yadav. I'm the maintainer at CNCF Porter. So CNCF Porter is a project by Cloud Native Cloud Foundation. So it is used to build the CNAP bundles. So you can take a look at CNCF sandbox projects about more about the portal. I'm also a Kaggle notebook master, and I'm currently working in the field of data science and solving day-to-day NLP and computer vision problem from past 1 year. I also working on the cloud native technologies like and MLOps and GitOps, exploring more technologies like Argo CD, Flux, Falco, and different kind of like stuff. So let's move ahead and discuss how you can monitor your own Kubernetes cluster. So first and foremost thing we need, like why we need to monitor our own Kubernetes cluster, why monitoring is needed. So let's say let understand this with a very small example. Let's say you are working on a large scale project. It is similar to like Amazon.com website. So let's say you are building a Amazon.com website. Inside that, we are following a microservice architecture. So we are having different kind of microservices. Let's say we are having a account service, web API, an inventory service, and a shopping service, or you can say like a checkout service, add to the cart service, searching in the categories. You are also having Amazon Pay inside it. So these all we can consider it into a single microservice. So what we have done, like we have built it over the microservices. Now it's time to release our whole architecture to the production mode. So for releasing it to the production mode, what we have done, we have used the Docker, containerized each microservices, and then what we have used a container orchestration tool. Let's say there are many container orchestration tools which are available in the market, but the most proper container orchestration tools are like Kubernetes and OpenShift. So these two are one of the most used container orchestration, or you can say container management tool present in the market. So let's say you have containerized your application. Now you are ready to deploy it to the Kubernetes cluster. So once you have deployed your containers in the worker nodes in the Kubernetes cluster, now you need some system to monitor your Kubernetes cluster. So why we need to monitor our Kubernetes cluster? Let's say you have deployed your service, but you want to take a look at its logs and metrics. You don't know when the error will be occur, or your application get into the failure state, or your application is healthy. So there are two options to monitor your Kubernetes cluster. The first option is to sit in front of your system whole day, 24 hours, and monitor each and every services, application, containers, pods, nodes running in your Kubernetes cluster. it is a very tedious task, and you will like it is a totally a waste of your time. The second thing what we have thought like to make the developer life easy is to create a some kind of automation tool. Let's say this tool will be like you can take example like we a tool which can scrap the metrics automatically, logs or metrics and logs automatically from your Kubernetes cluster or your Docker application or your pods or your nodes which are running inside your Kubernetes cluster, and send it to the and send it to the like any like to a dashboard where you can monitor where you can get a beautiful a heapster, C advisor, and different kind of a tools. So what in this video we will see about like what is ELK, what is ELK, how we can utilize ELK stack to monitor our Kubernetes cluster. So what ELK stack stand for? ELK stack stands for Elastic, Logstash, and Kibana. So these all three tools are built by a very famous organization which is known as Elastic. So you can take a look onto their site. They have a awesome implementation of these three all tools, and these tools are very powerful to do like tasks like monitoring, aggregating of the logs, searching the logs, and visualization of the logs. So here let's discuss about the each component step by step. So the first component here come into the picture is beats. So what are the purpose of the beats? So beats are one of the component by Elastic. So beats are used to collect and ship the logs. So what will beats will do? Let's say you have your Kubernetes cluster up and running. It can be anywhere. It can be into your Azure. It can be into your GCP. It can be your AWS Elastic Kubernetes services. So what will Beats will do? Beats will go to your Kubernetes cluster, scrap its log metrics, file metrics, and all the like container you want to check whether your application is running healthy or not. You want to check what resource utilization is it requiring. It is or it is like it is not having enough resources to run new pods or new worker nodes. So using monitoring, you can get all these insight, like whether your cluster is healthy or not, what resources it is utilizing, is it need more resources to be allocated. So if you are doing like stuffs like monitoring, you can easily get to know how you can scale up your Kubernetes cluster or require more replicas or require more resources. So what Beats will do? Beats will go to the Kubernetes cluster, Kubernetes, and say, "Hey Kubernetes, give me the logs and metrics of yours." So so Beats will be helpful to take the logs and the metrics of the pods, of your worker nodes, of your metrics, of your like good Docker application, and any other things, every other thing present into your into your Kubernetes cluster. So you can take a look all over your Kubernetes cluster, like file metrics, logs, metrics, and every other thing. So these are the things of the Beats. Like Beats will collect all your logs from the Kubernetes cluster and then ship it to the Logstash. So what is the purpose of the Logstash here? The main purpose of the Logstash is to pre-process and parse the logs. So you can say Logstash serve as a component which will format your logs according to format and pre-process your logs, which Elastic will accept. So what Logstash will do? It will pre-process all the logs and make it into available to that format which Elastic will accept it. So once Logstash will format, or you can say it will pre-process all the logs which it has got from the Beats. So it will forward those pre-processed log to the Elasticsearch. So what is the purpose of the Elasticsearch? So Elasticsearch is one of the most famous tool which is by the Elastic organization. So what is the purpose of the Elasticsearch? The main purpose of the Elasticsearch is to store the logs, and you can easily search the logs in the real time. So Elasticsearch made the searching of the logs in the real time very easy. Let's say you want to search a application which is running inside your pod. So let's say you are running a Redis database. So you want to search how my Redis database is performing. What are its logs? What are its metrics? So in the real time. So what you will do, like if you are using Elasticsearch, Logstash will send those application logs to the Elasticsearch, and from Elasticsearch you can easily perform those operations like searching of the logs, filtering of the logs, and in fact it is also a powerful database. In Elasticsearch you can easily store your logs, your pre-processed logs, and it will stay for a very long time. So once we have stored all our logs, all our pre-processed logs inside the Elasticsearch, then what we can do, we can send. Now we want to take a beautiful look of our logs. Like let's say we want to have like a plots, various interactive plots. We also want to set alerts. So what we can use? There is a fourth component of the Elastic is Kibana. Kibana are majorly used for visualization. Let's say you want to visualize the logs and metrics, so you can easily use Kibana to get the interactive plots, and you can say like interactive plots in the real time, like bar chart, pie chart, and different other kind of a plots. You can even set the alerts. Let's say you are sleeping at a night and your application got crashed, or you can say you have set up one condition, like when my replicas are moving above 5, so give me a alert into my email, give me a alert into my Slack, give me a notification into my phone. So you can easily set up the alerts into the Kibana. So it is similar to like Grafana, but there are some difference between them. So you can easily visualize logs using the Kibana. So what we have done, like Beats will collect and ship the logs from your Kubernetes cluster. Inside Kubernetes cluster, from each and every component like pods, worker nodes, and master nodes and Docker containers, applications running inside it. You can even fetch the system logs from using the Beats. So once you have collected and ship the logs, you will ship the logs to a Logstash. Logstash will pre-process your logs according to the format which Elasticsearch accept. So once you have pre-processed your logs, you will send into the Elasticsearch. From Elasticsearch, we can store the logs and do the real-time searching, filtering of the logs. Then after Elasticsearch, these logs will be sent into the Kibana dashboards, where you can easily visualize your logs in a beautiful way. You can plot interactive plots, and you can set the alerts for it. So this whole is called the Elastic Logstash and Kibana stack. So using this, we can monitor our Kubernetes cluster. In fact, you can also have some subscriber messaging system between Beats and Logstash. Let's say you can even put like Kafka, or you can even put like RabbitMQ between them. So these you can attach as many as applications you want. So it will be like good to visualize them and monitor them into the Kibana dashboard. So it is one of the powerful stack to monitor your Kubernetes cluster in the real time. So let's take a look onto like more about beats. So this is a definition which is properly present inside the in the Elastic organization. Like it is given by the Elastic. So there are two type of beats which we are utilizing here. The first beat is file beat, and the second beat is the metric beat. So like file beat are the lightweight shippers. You can use file beats to get the data from the files, from the log files, and you can collect it, and like you can even collect the log events and forward them to Elasticsearch or Logstash. So file beat are majorly used to get a centralized log data. This data can be from your files. These data can be from your like different files which are running inside the container. So you can get the data when you want to get the data from the files. You can easily use the file beat to get those data. The another thing here is metric beat. Metric beat is also a lightweight shipper. You can use the metric beat to collect the metrics. Let's say you want to collect the Docker container metrics, its telemetry data. You can easily collect using the metric beat. So what metric beat will do? It will collect the data, or you can say more precisely metrics from your. You can collect the metrics from your system logs. You can collect the metrics from a client application. You can collect the metrics from the servers also. let's say your Kubernetes cluster is running in the AWS EKS, so you can easily get them from you can easily get those things, get those metrics from using the metric beat, and then you can send it either to the Logstash or you can send it either to the Elasticsearch to pre-process or store your data, store your metrics and logs according to your purpose. So let's move ahead and see, like, so here it is a very beautiful diagram which I have taken from the Google Images. So you can say, like, see here, like we are having a Kubernetes node. Inside the Kubernetes node we are seeing, like, we are having a worker node. Inside the worker node, each container are running inside the pods. So you can say that there are multiple containers are running, and here is our operating system. So what FileBeat will do, it will collect the logs. You can consider FileBeat agent. It will collect the logs. FileBeat is used to collect the logs. Metric beats are used to collect the metrics. So it will collect the logs from the container. We will collect the logs from the container using the FileBeat. Then we will collect the metrics of the container. Let's say in the container there are multiple applications are running. Let's say you are running a Node.js application, you are running a Django application. So we can get the container metrics using the metric beat agent. So these two are one of the most popular use beats inside the when we are dealing with any monitoring system, we are building any monitoring system. So we will deploy these both beats inside our Kubernetes cluster. So it will pull the metrics and the logs automatically. Then these metrics and logs are sent to the Elasticsearch, and then we are getting a beautiful visualization dashboards using the Kibana. So the next thing, it is a very similar diagram which we have seen previously. Like it is a more like a flow diagram. Like we are having Kubernetes, then we are having a beats, then we are having a Logstash, then it is sent to the Elastic, then we are having a Kibana. Just there is some difference between, like, we can also collect the system log metrics. We can also collect like CPU utilization. We can also collect like how many resources are utilized from in our PC, in our desktop. We can also collect those things and get a visualization inside our Kibana dashboard. You can also collect like logs of a client application. Let's say you are running any Flask application, so you can easily get all those its logs and its metrics using using the you can easily get the logs and the metrics of it, and then you can send it into the Logstash for pre-processing. Then it will send to the Elasticsearch for searching and storing, and then you can get a beautiful visualization from on your dashboards using the Kibana. So this is all the setup of our basic ELK stack, Elastic, Logstash, and Kibana. So using it, you can easily monitor your Kubernetes cluster, day-to-day tasks. So it is ultimately making the developer life easy. So you can monitor your Kubernetes cluster. In fact, you can even set the alerts. So you can even get the alerts when your application is going down, or let's say you need more replicas of you need more replicas of your nodes. So you can even create a more replicas. Let's say you have set a default replica set equals to 5. Now your Kubernetes cluster needs more replicas. So you can get the alerts using this Kibana dashboards or alerts into your like messaging system, like email, like hey, you need to increase your replica sets. So you can easily go to your Kubernetes cluster and just increase the node count or you can just edit your YAML file. There you can mention your increase the number of the replica set. So it is a very powerful tool. So let's go back and see one it is a very good diagram, this one. So what here we are doing, like we are having a, you can see, like we are having a similar website like Amazon.com. It is built up on the React, and it is running on this host, or it is running on this uh, website. So what you can do, like now we have containerized all the microservices. Now we have deployed it into the Amazon EKS. So once we have deployed it into the Elastic Kubernetes services, now what we can do, one of the best thing which AWS provide is the ELB, Elastic Load Balancer. So you can apply the Elastic Load Balancer onto the each Nginx servers, and you can easily deploy your microservices. After it, you can deploy your ELK stack to monitor this whole Elastic Kubernetes services. So you can easily monitor it using the ELK stack and get the beautiful visualization logs and alerts onto your system. So that's it for this video. Then in the next video, I will show you how you can set up your own ELK stack into your system. And using the Civo Cloud, we will utilize Civo Cloud for setting up the Kubernetes cluster into our system, and then we will deploy a whole ELK stack over it. We will also see, like, in the upcoming videos, I will also tell you about like how you can do distributed tracing using Jaeger and other tools like Captain and Knative. So do subscribe my channel, and if you like this video, so do like it. So till then, bye and good day. Okay, so let's say take some like questions which are in the chat. So I'm seeing like some question like what are the limitation of using any of these tools. So there are like not such any limitations. We can use these tools anywhere when we need to monitor even our own system logs. We can use it. There are many other tools also present in the market like Prometheus and Grafana. There are some tools like C Advisor, Heapster, different kind of tools present in our market. So we can utilize any of these tools. These all tools are built for to make the developer life easy. So you can't select these any kind of such kind of limitations. But like there are like more better stacks which are present like Prometheus, which will not only extract your Kubernetes cluster metrics. It will be also helpful to extract more other things. Let's say you want to extract the metrics from our Node.js app. You want to extract the metrics from the Django app. So you can easily get through these, get the get extracted those metrics easily. So you can use any stack which you like feel like good to monitor your Kubernetes cluster or any other thing. You can easily use that. Like there are Prometheus with Grafana. Grafana is a similar thing like Kibana. These both are used for visualization of your Kubernetes, visualization of the logs and metrics. And you can also use like there's something called Heapster and C Advisor. You can also take a look onto it. And the third one is our popular ELK stack by Elastic. You can also take a look onto it and deploy it onto a Kubernetes cluster and do the monitoring. If we don't want to use ELB, does it affect our monitoring process very much? Yes, yes. See, what is the use of the load balancer? Let's say you are having your like Amazon website. Let's say you are building a website similar to the Amazon, and now you have deployed that website into your like you have deployed your website into the production. Now in the use case like there's a festive season like Big Billion Day sale. There we will got too much traffic onto our website. So if we do not have like condition like load balancing, components like load balancing, so what it will be do in our monitoring process, like we will be not able to like distribute. First we will not able to like distribute the loads among the processes. Let's say the first task of our production model is to distribute the loads between the different components. So let's say our web application has facing too much load. Let's say our application is facing too much load inside our too much load. So what Elastic Load Balancer will do, it will create multiple replicas. It will ask Kubernetes to create a multiple replicas of our worker node, so that it can distribute the load easily among our cluster. So our application should not go down, and it will also work properly. So in the monitoring process, monitoring we will do generally after when we have deployed our application. The first part is to attach the load balancers. Then the second part is to deploy them into the container and connect both the AWS ELB and our containers together. Then after that we want to set up the monitoring. We will set up the monitoring. So what monitoring will help us to do? Like using monitoring, we can easily get the health of our entire cluster. We can easily get to know about the health of our entire cluster. So that we can monitor each and every component like master node, worker node, pods, nodes, how it is performing, whether it want more resources or how much resources it is utilizing. So elastic load balancer came into the picture at the first. We need to apply that elastic load balancer so that we can distribute the load among our container, or you can say we can distribute the loads among our replica sets. So once we have deployed the elastic load balancer, we will connect it to our containers so that it will work synchronously. So when the load will increase, Kubernetes will automatically create new replicas of it, and those replicas we can easily monitor to the using our any tool like Prometheus, or we can use ELK Stack or Heapster or any other thing. So monitoring process will not be affected too much because monitoring process is at the end of our, like you can say, path. First we have ELB, then we have containers, then we are having monitoring. I hope I have answered your questions, Shikhar. Yeah. So if anyone have any question, you can ping me in my Telegram, in my LinkedIn. You can find me on LinkedIn. You can find me on Twitter. I will be happy to answer your all question. So yeah, welcome, Shiva. So I will be happy to answer your all questions. So till then, let's in the next video we will discuss all about like setting up, how you can set up it into your own own local devices, and then we will go ahead for other cloud technologies. Like we will also discuss about GitOps using like Argo CD and different other tools. So till then, you can follow me on my social medias and you can connect with me. I will drop the links into the description section, so you can connect with me. And till then, bye everyone, and do like and share the video. Bye.